Welcome back to You Revise, where we talk about everything exams. Let's take a look at question 1 from the 2017 exam, and the question reads, which one of the following pairs contain a strong acid and a weak acid? Key thing is a strong acid, and we are looking for an answer with a weak acid as well in the answer. Now, 88% of candidates got this question right. So like I say all the time to my students, don't hunt for the correct answer. Try to focus on justifying why the answers are wrong. Eliminate wrong answers. If you can comfortably eliminate wrong answers with multi-choice questions, then it kind of like helps with your emotional intelligence during the exam. You're not gonna be panicking because you would know at least I have done a good job of eliminating what I think is not correct. If you get to a point where you have to guess and you have managed to eliminate some answers that are wrong and you have confidently eliminated answers that are wrong, then your chances of getting a correct answer are increasing each time you eliminate an incorrect answer. So justify why a particular answer is not correct. So let's take a look at the first answer. We've got hydrochloric acid and sodium hydroxide. In this question, hydrochloric acid is indeed a strong acid, but sodium hydroxide is not an acid at all. It is a strong base. So this one here, sodium hydroxide, is a strong base. So this answer does not have a strong acid, and it has a strong acid, but it does not have a weak acid. It has a strong acid, but it does not have a weak acid. That's why this is wrong. Now, based on my suggestion earlier, now that we've eliminated this here, we can say we've got a 1 in 3 chance of getting a correct answer. Originally we had a 1 in 4, now, which was 25% chance. Now that has gone up to 33%, which is, a few percentage points up. Now let's take a look at answer B. Answer B, we've got magnesium carbonate and acetic acid. Now acetic acid is a weak acid, and magnesium carbonate is actually a carbonate, but it's basic. Why is magnesium carbonate basic? Magnesium carbonate is made up of magnesium and carbonate ions. Magnesium ions, carbonate ions are negative, not plus. Magnesium ions come from a strong base, which is magnesium hydroxide. How do I know this? Because according to the rules, all hydroxides and oxides of group 1 and 2 are considered strong bases. Right. Okay. Now, if we look at the carbonate ion comes from this weak acid, hydrogen carbonate ion. It comes from a hydrogen carbonate. It's a conjugate of this weak acid, the hydrogen carbonate, which means if this is a weak acid, this makes this a strong conjugate base. Because it's a strong conjugate base, if I take a carbonate ion, what it means is it can hydrolyze in water, releasing OH ions, which means this one would act as a base. It's a stronger base than water, so water would act as an acid in this case, according to Bronsted and Lowry. So water will donate a proton to that, and this one we end up with something like this. Because this can interact with water molecules in this process, which we call hydrolysis. In this process we call hydrolysis, releasing OH ions. These OH ions are basic. This is why we say magnesium carbonate is basic. Even though you didn't know magnesium carbonate is basic, but because it has got carbonate, it's not a base. We know that, it's not an acid, my bad. It's not an acid. So as a result, we need an both to be acids, because this one is a carbonate. It's not going to be an acid, but like at the end of the day, it's important for you to know this. Let's take a look at the next answer, which is ammonia and potassium hydroxide. Potassium hydroxide is a base, and ammonia is also a base. So we are looking for an answer that has got a strong acid and a weak acid. So therefore, we've eliminated this. So we've eliminated all these three answers comfortably. We are left with D. D has got nitric acid. Nitric acid is a strong acid, and carbonic acid is actually a weak acid. This makes this answer correct. How do I know which ones are strong, which ones are weak acids? There's a whole video on this one, which I'm going to link up to this so that you can click on that and go and watch that if it's of interest to you. I just don't want to make this video unnecessarily long. So I'll finish off this one here with our correct answer is D in this case. I shall see you when you attempt or look at the next questions. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.